Hey, this is Wyatt Greenwald,
And this is Bryce Watson,
and we're going to do the experiment for...
double displacement.
Alright. So what we're going to do here is get two 50 milliliter beakers, and we're going to add some materials. First thing we're going to add is the, if we're going to do 15 milliliters of the sodium hydroxide. So let me just put that in the beaker. Do 15 milliliters. And in the other beaker, we're going to go with 6 milliliters of nickel chloride. As you can see, the sodium hydroxide over here has kind of a cloudy gray color. Nickel chloride has a little bit of a green fluorescent type color.
So now we're going to mix the solutions by pouring the nickel chloride into the sodium hydroxide.
Without further ado,
Alright, pour all.
pour all.
There we go. You may want to zoom in here. Alright, so it's kind of hard to see, but there is a green precipitate that results from this reaction, which is
it's going to be nickel hydroxide.
yeah.
So the two products of this reaction were sodium chloride and nickel hydroxide. Being that we know sodium chloride is really soluble, we conclude that nickel hydroxide is the precipitate
From this reaction. Yes. It's always important to put away your materials.
Wait, where's that recycling bin at?
Down here.
Oh, okay.
Yeah.
Why's the waste? Oh, okay.
Just put it in there.
I'll just clean that up.
There we go. Always want to make sure your lab space is tidy and not leave anything out. Maybe we have
There we go.
Oh, there we go. All right.
And we are ready to go. Ready to do some calculations. Alright, so here we have the balanced chemical equation for the reaction that took place. So if you take it in terms of moles, 2 moles of sodium hydroxide and 1 mole of nickel 2 chloride will react to form 2 moles of sodium chloride and 1 mole of nickel hydroxide. And you can see this is a double displacement reaction because the cations in each molecule trade places. Sodium trades places with nickel 2 to create sodium chloride, and nickel trades places with sodium to create nickel 2 hydroxide. And if you do a little bit of calculations, you can get to figure out which reactant is the limiting reactant. So we have the 15 milliliter sodium hydroxide solution, which was 1 molar, and molarity is moles per liter. So we divide this by 1,000 to get liters. So we have 0.015 moles of sodium hydroxide in 15 milliliters. And we did the same thing with nickel 2 chloride, and you get 0.006 moles of nickel 2 chloride in 6 milliliters of the solution. And then we went on to find the number of moles of sodium chloride that the reactant produced. We have 2 moles of sodium hydroxide and 2 moles of sodium chloride. 2 moles of sodium hydroxide here makes 2 moles of sodium chloride here. Now, 0.015 moles of sodium hydroxide, you get 0.015 moles of sodium chloride. And then we did the same thing of our other reactant, nickel 2 chloride. So in 1 mole of nickel 2 chloride, you have 2 moles of sodium chloride. So if you look back at the balanced equation, all you need is 1 mole of nickel 2 chloride to make 2 moles of sodium chloride. And doing this, analyzing this, we found that the nickel 2 chloride only made 0.012 moles of sodium chloride, while the sodium hydroxide is capable of making 0.015. So we can see that there is an excess of sodium hydroxide.
Nickel 2 chloride is a limiting reactant because it can only produce 0.012 moles, meaning that's the maximum amount of moles of sodium chloride you can produce because it's limited by nickel 2 chloride.